That's the Clelland for Maths. Today we're doing National 5 Maths and it is area of a triangle. Remember it's half A, B sine C. Let's get into it straight away with all the questions. Now remember we've got our National 5 Maths app.clellandmaths.com to get on that completely free, and we are also taking a lot of these questions from maths.scot, an excellent website which is also helping with the app. So okay, example 1. In the triangle below, BC is 9, AC is 15 and angle C is 60. Calculate the area. So start of the exam paper tells you the area of a triangle. Area is a half AB sine C. Now you just need to identify A, B and C, but don't worry about the letters here. For this question it does work out, but really it's the two sides with the angle in between. The two sides get times and you use the angle in between. So I've got that, so that's a half times 9 times 15 times sine 60. We'll just get a calculator to work that out. A half 0.5, so I always just type that in, times 9 times 15 times sine 60 is 58.456, which we can just round if you want to 58.5 if you want millimeters squared. Make sure you've got your units, and we're done there. Okay, example 2, an area of a triangle. In the triangle below, AB is 5, BC is 3, and sine B is 1 over root 2. So this is a non-calculator question, but don't be put off by that. We've still got the same formula, a half AB sine C. But when a question in a non-calculator paper tells you the sine of the angle equals that, then that gets replaced by the sine. Now if they're saying sine B, don't worry about the letters. B is here, as long as you've got the two sides that make up the angle, those are your two sides, and then your sine is the other thing. So I can just type in a half times 5 times 3, or 3 times 5. And then the sine of the angle is not sine 1 over root 2, it's just 1 over root 2. And then we'll try and work that out without a calculator. So that is 5 times 3 is 15, so I've got 15 over 2 times 1 over root 2. That's 15 over 2 root 2. Next bit of the question says leave your answer with a rational denominator. So we need to rationalise the denominator, check my surds video on that, but we just times by root 2 over root 2. So that gives me 15 root 2 on the top, and 2 times root 2 is also 2. So just about there, 15 root 2 over 4, and my units are centimetres squared. So it's a bit of a funky answer, but we're done there. Okay, example 3 on area of a triangle. Calculate the area of an equilateral triangle of size 5. Well, let's draw this one out. An equilateral triangle looks something like this. Not quite exact there, but close enough. It means all the sides are the same. So all the sides are 5, so let me just label 2 of them. And then the angle in an equilateral triangle, all the angles are the same, so it's 60. So it's getting you to think about that. And then its area equals a half AB sine C. So that's a half times 5 times 5 times the sine of the angle in between, which is 60. Get my calculator for that then. A half 0.5 times 5 times 5 times sine 60 is 10.825. Or about 10.8 centimetres squared to 1 decimal place. Always write down your unrounded answer first. If the question's not asking you to round, it doesn't matter that much. Example 4, an area of a triangle. Calculate the area of a regular hexagon of length 10. It doesn't look like it's a triangle question, but let's have a look. A hexagon looks something like this. It's quite good for me. And the side it says is 10. So I wonder, could I split this up into equal triangles and work out it as a triangle problem instead? Well, let's take where the centre of this hexagon is. If I did that and did that, I would have one triangle, but I could keep doing that all the way around to get 6 equal triangles. So now the problem becomes is, where's my angle going to be? Well, angle is at the centre. There's 6 angles around the centre, so 360 divided by 6 would tell me that angle. 6 sixes is 36, so that's 60 degrees. So since that's 60, because of symmetry, then these are equilateral triangles, so that would be 10 as well here. and that would be 10 there. So our area is a half AB sine C, which is a half times 10 times 10 times the sine of 60. Getting a calculator, 0.5 times 10 times 10 times sine 60 is 43.3 centimetres squared, and that's just one of the triangles, so now I need to work out all 6. So times them by 6, our area is 43.3 times 6, 259.8, and then it was to 3 significant figures, so that is just 260 centimetres squared, and we're done there. Example 5 on area of a triangle. Now remember, we've got our members only live streams every single week, so get on that if you want some extra help. Triangle of area 50 has 2 sides, lengths 12 and 10. Find the angle between these 2 sides. Well, let's just draw a sketch so we can see what's happening here. We've got, this is just a rubber sketch, but we've got a triangle. We say that the area of that equals 50 centimetres squared. And we say that one of the sides is 12, say, and one is 10. I'll just pick the 2 sides. And we'll have to find the angle in between. Let's just call that angle C then. Area equals a half AB sine C. So area is 50. That equals a half times 10 times 12 sine C. Work out as much as I possibly can. A half of 10 is 5 times 12 is 60. So I get 60 sine C. So that means that sine C must be 50 over 60. No need to simplify because I can just do inverse sine now. So C is the inverse sine of 50 over 60, or 5 over 6. Shift sine 50 over 60 is 56.4 degrees. And we're done there. Example 6. A triangle of area 50 has 2 sides, 12 and 10. The angle between the 2 sides is obtuse. Find the angle. Looks like the same question in example 5, but it is not. So you've got a triangle. So let's say we had something like that. To give me an obtuse angle here, let's call that C, and let's call that 10 and 12. So area is a half AB sine C again. I'll do the full work for it. 50 is a half AB times 10 times 12 sine C. So 50 equals a half of 10 is 5 times 12 is 60 sine C. So sine C is still 50 over 60. So if I do the inverse sine of 50 over 60, I get an answer, which we've already done before, 56.4 degrees. But that is not C, because it says in the question it's obtuse. Well, how do we find another angle that gives the same answer? A cast diagram. So if I draw a cast diagram, then sine is positive. So I could do the second one. C is equal to 180 minus 56.4, because that gives me an angle over 90 but less than 180. 180 minus 56.4 is 123.6, and that is our angle. Quite a tough question, that one, and you need to know your knowledge of trig equations, so watch a video on that if you're still stuck. National 5 Maths 2015, paper 2, question 11 had this question. The tabletop is in the shape of a regular hexagon. The 3 diagonals are shown in dotted lines below. Each have a length of 40. Calculate the area of the tabletop. So we know that each of these lines here, the diagonals are 40, which means half in it, these will be 20. Now, it's an area of a triangle question in disguise. There's a bunch of triangles here, not all the same size. So if I draw one of the triangles, you should be able to see that it is an isosceles triangle, not an equilateral triangle. And therefore, every angle is 60 degrees. The way to find out it's 60 is because it is a hexagon. There's 1, 2, 3, 4, 5, 6 angles around the centre. 360 divided by 6 is 60. And now we can use area of a triangle. So let's look at this triangle. We can call that C, A and B. That could be A, and that could be B, sorry, and that could be A. So now area is a half AB sine C. So that's 0.5 times 20 times 20 times the sine of 60 degrees. Again, it's a calculator question, so just get your calculator out and work it out. That'll be 173.2 square centimetres. But if we go back to the original question, you'll notice that there's 1, 2, 3, 4, 5, 6 triangles in there. So our total area, we need to times that by 6. Get 1039.2 centimetres squared for our final answer. We have a triangle with trigonometry. This is given to you at the start of the exam paper. Just a reminder that it tells you that the area is a half AB sine C. And we're going to look at a bunch of questions that use this idea. So SQA National 5 Maths 2017 paper 1 question 7 had DE is 8, EF is 12 and sine of E is 2/3. Notice this is a non-calculator question, so it's telling you the sine of the angle so that you don't have to work it out already. So the main key point with this is the angle is always in between the two known sides to do the area. So that angle is always our C. So if I want to relabel it, I could call that C, and then that could be A, and that could be B, to give me my little A and my little B here. Well, it's just a substitution. The area is a half of 12 times 8 times the sine of E. Well, C we've called it now, so that would be called sine C. So that gives us 0.5 times 12 times 8 times the sine 2/3. We'll need to do some work here. 0.5 times 12 is 6. 6 times 8 is 48. So quite quickly we get to 48 times 2/3. And then if you divide 48 by 3, 3 goes into 4 one time. With 1 left over, 3 6 is 18, so that's 16 times 2. So our final answer of 32 square units, which is centimetres. And we're done there. National 5 Maths 2019, Paper 2, Question 13. So for this one, again, we've got our angle, so we'll call that our C, and then the other two sides could be our A and our B, and that would be our A, and that would be our B. Calculate the area of triangle PQR. So the area is a half AB sine C. So for a mark, 0.5 times 70 times 45 times the sine of 129. You get a mark for the substitution. And then a mark for the final answer. You just get your calculator out and do 0.5 times 70 times 45 times sine 129 in the calculator. And you will get 1224.004. So that would be fine to leave it as 1224 square centimetres. SQA National 5 Maths 2023 Paper 2 Question 15. AC is perpendicular to BC, AB is 18, BD is 6, BC is 8. The area of a triangle is 160. Calculate the length of AE. Area of a triangle. Right, let's start with that then. Area of a triangle is a half AB sine C. And by A and B we mean the two lines over the angle. Now, we don't know this angle, but we do know this length here, which is 18 plus 6. So we know the whole area, we know this length, and we have to calculate this length. So if we knew this angle, we'd be good to go, because we could just work backwards. Well, that angle's fine. Sine of this angle, let's call it theta. Sine theta is equal to the opposite, 8 over the hypotenuse 18, just from SOHCAHTOA and basic trig. So I can replace sine C with 8 over 18. So that means our area is equal to a half times this length, 18 and 6 is 24, times this length, which is A to E, I suppose we could call it. I'll just call that AE for clarity, times our sine of the angle in between, which is this one, which is 8/18. But remember, our area is 160, so a half of 24 is 12, so we've got 12 times 8/18 times E equals 160. So we can work on that. 12 times 8 is 96, so we get 96/18 times some side AE equals 160. So rearranging that then, AE must equal 18 times 160 divided by the top of 96. 18 times 160 divided by 96 is 30. So our length is 30 centimetres. SQA National 5 Maths 2025, Paper 1, Question 5. Triangle ABC is shown, AB and BC are 6. Sine B is 2/3, find the area. So start of the exam paper, area is a half, AB sine C. Doesn't matter about this, all that matters is that angle in between is the one you're looking at, two sides. So angle in between I've got, and two sides. So the area is a half times 6 times 6. And it tells you the sine of the angle, so I just write 2/3, because it's non-calculator. A half of 6 is 3. And then I can do 2/3 of 6. 6 divided by 3 is 2, times 2 is 4. So I get 3 times 4, which is 12 centimetres squared for the area. And we're done there. This has been Mr. Clelland for Clelland Maths. Today we did the whole of area of a triangle in National 5 Maths. Hopefully you found that useful. Remember, we've got our members only live streams every single week, and we've got our National 5 app at app.clellandmaths.com. Take care, stay safe, and goodbye.